Okay, this video will going to explain to you the using elimination method to rewrite a system in a row echelon form. So the main goal of rewriting a system into a row echelon form is to make the system very easy to solve, in which when it will become in when the system is in a row echelon form, you can already use the back substitution method to solve for its variable. But this time, I will going to show you how to rewrite the system by using the elimination method. Now, our goal here is we can transform these systems into a system in which each of the variable has only has a leading coefficient of 1. So how are we going to do this? So we just simply follow the operations, the steps or operations of the systems to produce an equivalent system also. So the first thing to do here is we need to find equations that we can eliminate one of its variables. So obviously we have here equation 1 and equation 2. If we were going to add the two equations, we can eliminate one of its variable. So for this transformation, let's assume that this is R1, this is R1, R2, and R3. So for this transformation, what we did is we add R1 plus R2 to create the second equation or new equation. So we just simply copy the first one. It's minus 2y plus 3z equals 9. And for the second equation is the sum of R1 and R2. So the sum of R1 and R2 is, this is cancelled out. So the remaining will be y plus 3z equals 5. So as you have observed, x has a leading coefficient of 1, so we get it done for the first equation. The second equation also has only y here is having a leading coefficient of 1, so it's already done. So we need to have a leading coefficient of 1 in the variable z. So forget, we just simply copy the third one plus 5z equals 17. So again, we will find another equation so that we can eliminate one of its variable. So obviously we can use R1 and R3. We need to multiply R1 by negative 2 to eliminate a negative 2 here in R3. So for this transformation, this transformation is for this, the R3 equation. So we need to multiply. So negative 2 R1, and we will going to add it by R3. So simply copy the first equation, x minus 2y plus 3z equals 9. The second equation also, y plus 3z equals 5. And for the third one is the sum of this. So if we were going to multiply this by 2, negative 2, so it will become negative 2x plus 4y minus 6z equals negative 18. So by simply adding the 2, this one, so we came up an equation which is negative y minus z equals negative 1. So we're not yet finished. It's because we should have here z only, no, because we need to transform it into a row echelon form. So another transformation, so for this transformation, since we're not yet done, we will use this one, R2 and R3. We can add R2 and R3. So again, let us copy the first equation since it is already in a row echelon. So that's 3z y, and also for the second one. So for the third equation is the sum of R2 plus R3. So the sum of R2 and R3 is, so cancel, it will become 2z equal to 4. So we need to, actually it is already a what we need to do just here is to simplify it in a simplified form. So z should be, you will multiply it by 1/2. It will become z is equal to 2. So the row echelon form of this system is, so this will be the final one. The row echelon of this is x minus 2y plus 3z equals 9, y plus 3z equals 5, and z is equal to 2. So as you observe, each of the process, we are eliminating one of its variable. So let us recall. For this, from the first one, we have eliminated x. So we have here the second one, we also eliminate x. So here, which becomes negative y minus z equals negative 1. And again, we eliminate for this transformation, we eliminate variable y here. So it becomes here, and we just, what we did here is we just do the simplest form. We get a simplest form of this equation. So this is the new transformation from this equation to this. By using the elimination method, we get the row echelon forms of these equations.